Geometry 4-3, Congruent Triangles. So we're going to write a little bit here. If two geometric shapes have exactly the same shape, and same size, they are congruent. So that's the congruent sign, congruent. All right, so if two shapes have the same shape and the same size, then they are congruent. So let's draw a couple shapes here, like that. And then we'll draw it like the same shape on its side, like that. So it should be pretty much the same shape. These are congruent. So it's okay if they're rotated. They're still congruent. It's okay if they are flipped or mirrored. They are still considered congruent even if they are rotated or flipped or mirrored. Definition of congruent polygons. Definition of congruent polygons. So two polygons are congruent if and only if their corresponding parts are congruent. So if I have two polygons, they are congruent if and only if their corresponding parts are congruent. So let's do, let's draw a couple triangles. Okay, two triangles, and these triangles are, okay, it's okay. A, B, C, and K, J, H. So if you're looking on the notes that we have, that I have online, this might look a little bit different, but it's the same principle here. So C and K are congruent, and B is congruent to J, and A is congruent to H. Let's start with BC is congruent to JK, JH is congruent to BA, and AC is congruent to KH. Okay, so here's something you might see on the homework. List corresponding parts. And so I'm going to say AB, segment AB, is congruent to segment HJ. Notice how I'm going in the same direction, from A to B, from H to J. BC segment BC is congruent to segment JK. And then CA is congruent to KH. All right, so those are the sides. We also need to list the corresponding angles. So I've got all the sides and now the angles. Angle A is congruent to angle H. Angle B is congruent to angle J, and angle C is congruent to angle K. All right, so now once all of the corresponding parts are listed, then we also need to write a statement of congruence. And so I'm going to say triangle B, triangle ABC is congruent to triangle. Now, order matters. So I know that A is congruent to H, so I'm going to put H here. And B is congruent to J, I'm going to put that there. C is congruent to K, so I'm going to put that there. Order is important. So order matters. So notice how I have A and H, B and J, and C and K. So those are all, the order of the triangle matters. So we're going to do an example here. I'm actually going to go ahead and do this as your first part. Well, actually, we'll finish this example here. Let's do this example. So this example is LKJ, and LJ is 50, JK is 39, and LK is 40. L is 50 degrees, J is 52 degrees, and K is 78 degrees. Now we have another triangle that is PMQ. MQ is 40, PQ is 50, and PM is 39. These triangles are definitely not drawn to scale here. P is 52 degrees, angle M is 78 degrees, and angle Q is 50 degrees. So if you look at these two, I want a statement of congruence. So if I look at these two here, I am going to pay attention to which angles are the same and which sides are the same. Sometimes with the statement of congruence, the easiest way to do it is just to look at the angles. And so I'm just going to start with, I'm going to say triangle, and then I'm going to just start with this L here. So L, I find the corresponding angle to angle L, 50 degrees here. Q is also 50 degrees. So I'm going to say it's congruent to triangle Q, and then I'm going to fill in the other points here. So L is 50, J is 52, J, Q is 50, P is 52, P. So now I have L, J, K, and I have Q, P, M. So L and Q are corresponding, they're 50 degrees. J and P are corresponding, they are 52 degrees. And M and K are corresponding, and they are 78 degrees. So that would be your statement of congruence. We're going to do another example. And I'm given a triangle, ABC, is congruent to another triangle, triangle DFE. So I'm going to draw this triangle ABC. AB is 32.1, BC is 38.4, AC is 54. Angle A is 45 degrees, angle B is 99 degrees, and angle C is 36 degrees. Now I'm going to draw this other triangle, DFE. And F is 8y minus 5 degrees. Angle D is 2a plus 15 degrees. And FE, this segment here, is 2y plus x. I want to know what A is, I want to know what x is, and I want to know what y is. The value of x, A, x, and y. Okay, so I'm going to actually, instead of doing this all together, first, I would like you to see if you can go ahead and find these values. So give it a try, pause the video, and then we'll do it together in a moment. Go. All right, let's go ahead and check these out. So if I'm looking at my triangles, I can see they are both just set up so that B is corresponding with F, and A and D are corresponding, and C and E are corresponding. So they're laid out easy for me to find which angle goes with which angle. So I'm going to solve for A first, and A and D are corresponding, and these are congruent triangles, so that means that A equals D, so 45 degrees equals 2A plus 15 degrees. So I'm just going to subtract 15 from each side. I get 30 equals 2A, divide by 2. A equals 15. Now I'm going to go ahead and look at angle F, and I have 99 equals 8y minus 5. B and F are corresponding and congruent. So I'm going to set those equal to one another. Now, if you couldn't really tell with the triangles which angles were corresponding, you can look in the congruency statement here. A and D are congruent because they are in the same place in the congruency statement. B and F are congruent because they are in the same place in the congruency statement. So if the triangles were a little bit hard to read which one goes with which, you can look up here in this statement and that'll tell you as well. I'm going to add 5 to each side. 104 equals 8y, divide both sides by 8. Y equals 104 divided by 8. Gross, 13. Yeah, 13. Okay, now I have FE and BC, those are corresponding sides, and I just set 2y plus x equal to 38.4. And I'm going to plug 13 in for 2. And so that becomes 26 plus x equals 38.4. Subtract 26 from each side. X equals 38.4 minus 26, which would give me 12.4. All right, that's how you do that one. Now we're going to look at a little bit more here for this part of for 4-3. We're going to do some proofs, or we're going to do at least one proof here. One proof. Prove triangles congruent. And we have a third angles theorem. If triangle ABC, and I've got another triangle KLJ or LKJ, okay. If C is congruent to K, and B is congruent to S. If these two angles are congruent and these two angles are congruent, then these two angles have to also be congruent. Then angle A is congruent to angle L. Because if this and this were the same number, which they are, a degree measure, and these two are also the same degree measure, if I were to add those up and subtract that from 180 to get A, I would do the same thing over here, subtract these from 180 to get L, and I would find that A and L are congruent. So we're going to do a quick little proof here. Hopefully. All right, here's your given. DE is congruent to GE segments. Segment DF is congruent to segment GF. Angle D is congruent to angle G. Angle DFE is congruent to angle GFE. Prove triangle DEF is congruent to triangle GEF. And you have a little diagram over here. On the left is D, on the top is E, to the right is G, and the bottom is F. So we know that D and G are congruent. We know that DE and GE are congruent, DE and GE. DF and GF, DF and GF are congruent. Angle D and G, we got that one. DFE, DFE is congruent to GFE, so these two angles are congruent as well. Now, we want to prove that this triangle is congruent to this triangle. All right, statements and reasons. So instead of writing all of this given like I should do, like a good math teacher, I'm not going to do that. It goes right there and given. So all of this stuff would go right there. Sorry. Now, I know that any segment is congruent to itself. What I need to do here, my plan, is to say that all of these corresponding sides are congruent. The sides here, corresponding sides from this triangle, are congruent to the corresponding sides from this triangle. And all the angles here that are corresponding to these angles are all congruent. I have to prove that all of those parts are congruent in order to say these triangles are congruent. So I'm going to say EF is congruent to EF. EF is congruent to segment EF. And that is the reflexive property. Reflexive property of congruence. And so now I have all of those sides are congruent. Those two sides are congruent. We already know these two are congruent. Now these two are congruent. Now I need to say that DEF is congruent to FEG or GEF. Okay, so angle DEF is congruent to angle GEF. And I know that because of the third angles theorem we just learned. If I have two angles that are congruent to two other angles in triangles, then the third angle also is congruent. So, third angles theorem. Oh gosh, I wrote theorem wrong, didn't I? Theorem. Gross. Okay. Now I can say triangle DEF is congruent to triangle GEF. Definition of congruent polygons that we just learned at the beginning of this lesson, where if all of the sides and angles, all of the parts are congruent, corresponding parts are congruent, then the polygons are congruent. Whew, and that is 4-3. All right, good luck on the homework.